Hello, welcome to Astronautics for Exploit. This is Dr. Anyashola Ogudele. Global race for space-based solar power, once thought to be a futuristic idea, now becoming a reality. The focus points are as follows: drivers of space-based solar power and countries investing in space-based solar power. Space-based solar power, once thought to be a futuristic idea, is gradually becoming a reality based on experiments carried out and various real-life demonstrations of its feasibility. In 1941, the idea of space-based solar power was described by science fiction writer Isaac Asimov in his short story, and since then it has been evolving. Presently, based on its enormous benefits, there is an ongoing global race for space-based solar power and exploration of the idea by several countries such as United States, China, European Union, Russia, Japan, India, and a host of others. The renewed interest in space-based solar power by the various countries is brought about because of low cost of launching spacecraft, constant availability, unaffected by bad weather, the seasons, nighttime, and cloud cover, advancement in the solar and robotic technologies, and the urgent need to replace fossil fuels with abundant renewable energy. Various ideas and concepts of space-based solar power are being tested and demonstrated. For example, in Japan, to test space-based solar power technology, researchers are working on a project to launch an aircraft equipped with solar panels that will be flying about 5 to 7 kilometers above sea level and beam back microwaves to the Earth. At the Earth, the ground receiving antenna will turn the received microwave into electricity. Drivers of space-based solar power. Space-based solar power is receiving high attention because of its various benefits. Various countries around the world are investing in space-based solar power research and development. Some of the drivers of space-based solar power are consistent power supply, clean energy, government solar power policies, and research and development. Concept of an electrically powered space dock equipped with a solar disk is illustrated in this picture. Space-based solar power can provide clean energy with zero emissions, energy day or night, and can pass through clouds, unlike ground-based solar, which is limited to daytime use and can be blocked by weather. Many government agencies are formulating solar power policies, and companies are pushing ahead with demonstration plans for space-based solar power. Artist depiction of space solar power demonstrator prototype is shown in this picture. Challenges of space-based solar power. Space-based solar power has some challenges such as cost, collisions, maintenance, and complexity. Findings show that space-based solar power could cost between 12 and 80 times as much as ground-based renewable energy sources, and the size and complexity of space-based solar power systems could increase the risk of collisions. Artist's concept of the transmission of space-based solar power is illustrated in this picture. Countries investing in space-based solar power are United States, European Union, China, India, Japan, Russia, and a host of others. The United States has been involved in space-based solar power research and development in several ways, such as the Space Solar Power Project, the U.S. Naval Research Laboratory Project, NASA projects, the Space Energy Initiative, and others. The Space Solar Power Project is working on high-efficiency solar cells, along with a conversion and transmission system optimized for use in space, while the United States Naval Research Lab tested a solar model and power conversion system in space in 2020. The picture here illustrates space-based solar power. NASA is developing technologies for its current mission portfolio that will indirectly benefit space-based solar power. Examples are projects focusing on the development of autonomous systems, wireless power beaming, and in-space servicing, assembling, and manufacturing. Some universities in the United States are engaging in space-based solar power projects. For example, in a first Caltech space solar power demonstrator wirelessly transmits power in space. The picture here illustrates the interior of MAPO with the transmission array to the right and receivers to the left. European Union. The European Space Agency is exploring the potential of space-based solar power to provide clean, reliable energy for Earth. ESA is working on Solaris project. The goal of Solaris is to prepare the ground for a possible decision in 2025 on the full development program by establishing technical, political, and programmatic viability of space-based solar power for terrestrial clean energy needs. Concept of European Space Agency Solaris project to study solar farms in space is illustrated in this picture. ESA Solaris approach involves collecting solar power in space with satellites equipped with solar panels, then transmit it wirelessly to receiving stations on Earth. The technology development includes studies and technology development in areas like high-efficiency solar source, wireless power transmission, and robotic in-orbit assembly. ESA is collaborating with Astrostrom on a model for a space-based solar power station, referred to as Greater Earth Lunar Power Station. Space-based solar power for Earth's energy needs is illustrated in this picture. China announced an ambitious plan to build solar power stations in space using super heavy rockets. The concept is referred to as another Three Girls Dam project above the Earth. China is planning a gigawatt-level space-based power station, and a spacecraft designer and manufacturer, the China Academy of Space Technology, is aiming to send the solar satellite into low orbit in 2028 and into high orbit by 2030. The Grand Recipient Verification System of China's space-based solar power station is illustrated in this system. India is interested in space-based solar power and has taken steps to develop the technology. Examples of India's solar power initiatives is Kalam NS's Indian American Energy Initiative. In 2010, India and United States announced a joint effort to develop space-based solar power satellites. The picture here illustrates space-based solar power station. Japan is planning to beam solar power from space to Earth. The development marks an important step towards a possible space-based solar power station, which could help wean the world off fossil fuels amid the intensifying battle against climate change. A group of Japanese researchers are launching an experiment to test technology of collecting solar energy in space and transmitting it to the Earth. Artist's impression of Japan's space agency of solar power satellite transmit energy down to Earth via lasers is illustrated in this picture. Russia has developed a project for a space-based solar power plant aiming to harness solar energy from space and beam it back to the Earth. Namia project was a notable example of Russia's early research in space-based solar power field, which involved deploying large reflective mirrors in orbit to test the concept of beaming sunlight to the ground. The project was abandoned after a failed deployment of the satellite. An illustration of Cassiopeia's solar power satellite is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Global Race for Space-Based Solar Power, once thought to be a futuristic idea, now becoming a reality. Presented by Dr. Ayanshola Ogundele, with a focus point, drivers of space-based solar power, and countries investing in space-based solar power. Thank you.